Imagine a world without electricity, where the night is truly dark and communication across distances takes days, if not weeks. Or consider a universe where the intricate dance of planets and stars is an unsolved mystery. Join us as we explore 7 stories of the greatest scientific discoveries that have transformed our understanding of the universe and our place within it. First, let's talk about electricity. Before its discovery, the world was lit by candle light and life ground to a halt after sunset. Can you imagine that? The story of electricity is a tapestry woven from the contributions of many great minds. In the 18th century, Benjamin Franklin famously flew a kite during a thunderstorm, proving that lightning is a form of electricity. This was a pivotal moment, but the real breakthrough came in the 19th century with Michael Faraday, whose experiments with electromagnetism laid the groundwork for the practical use of electricity. Faraday discovered that a changing magnetic field could produce an electric current, leading to the development of electric generators and transformers. Think about how essential these are today. Thomas Edison and Nikola Tesla later took these discoveries and revolutionized the world with their work on electric light and power distribution. Today, electricity powers our homes, fuels our industries, and drives technological innovation, making it one of the most transformative discoveries in human history. Next, consider the discovery of the structure of DNA, the molecule that carries the genetic instructions for life. Do you know how revolutionary this was? In the early 20th century, scientists knew that DNA played a crucial role in inheritance, but its structure remained a mystery. Enter James Watson and Francis Crick, who, in 1953, unveiled the double helix model of DNA. Their discovery was built on the critical work of Rosalind Franklin, whose X-ray diffraction images of DNA were instrumental in revealing its helical structure. This breakthrough has had profound implications for biology, medicine, and genetics. It has paved the way for advancements in genetic engineering, forensic science, and our understanding of hereditary diseases. The unraveling of the DNA double helix opened the door to the genetic revolution, transforming our ability to diagnose and treat illnesses and enhancing our understanding of the very essence of life. Our exploration continues with Isaac Newton, whose work in the 17th century laid the foundations for classical physics. Ever wondered why apples fall from trees or how planets stay in orbit? Newton's laws of motion and universal gravitation explained the movement of objects both on Earth and in the heavens. His work unified the celestial and terrestrial realms under a single framework, demonstrating that the same set of natural laws governed the motion of planets and apples falling from trees. Newton's Principia Mathematica, published in 1687, revolutionized our understanding of the physical world and established the principles that would guide scientific inquiry for centuries. His discoveries not only provided a comprehensive explanation of gravity and motion, but also introduced the concept of a universe governed by predictable and quantifiable laws. As we move into the 20th century, we encounter Albert Einstein, whose theory of relativity fundamentally changed our understanding of space, time, and gravity. Did you know how mind-bending this was at the time? In 1905, Einstein published his special theory of relativity, introducing the famous equation E equals mc, which revealed the interrelationship between mass and energy. 10 years later, he expanded his ideas into the general theory of relativity, which described gravity not as a force but as a curvature of spacetime caused by massive objects. This revolutionary perspective was confirmed by observations of light bending around the sun during a solar eclipse in 1919, dramatically shifting our understanding of the universe. Einstein's theories have had profound implications for cosmology, astrophysics, and even everyday technologies like GPS, which rely on precise calculations of time and space. Another monumental discovery came from the realm of chemistry with Dmitri Mendeleev and the periodic table. Have you ever marveled at how elements are organized? In 1869, Mendeleev published the first version of his periodic table, organizing the known elements based on their atomic weights and properties. His insightful arrangement revealed patterns that predicted the existence and properties of elements yet to be discovered. Mendeleev's periodic table provided a systematic framework for understanding chemical behavior and interactions, revolutionizing the field of chemistry. This discovery not only facilitated the identification of new elements but also laid the groundwork for advances in materials science, pharmacology, and countless other disciplines. In the field of biology, the theory of evolution by natural selection, proposed by Charles Darwin in 1859, has profoundly influenced our understanding of life on Earth. Ever wondered how all life forms are connected? In his groundbreaking work on the origin of species, Darwin presented evidence that all species of life have descended from common ancestors through a process of natural selection. This theory challenged the prevailing views of the time and provided a unifying explanation for the diversity of life. Evolutionary theory has become a cornerstone of modern biology, influencing fields as diverse as genetics, paleontology, and ecology. It has fundamentally altered our perspective on the origins and development of life, shaping our understanding of biological processes and the interconnectedness of all living organisms. Finally, let's explore the discovery of penicillin by Alexander Fleming in 1928, a breakthrough that revolutionized medicine. Imagine a world without antibiotics. While working with Staphylococcus bacteria, Fleming noticed that a mold called Penicillium notatum inhibited bacterial growth. This serendipitous observation led to the development of the first antibiotic, penicillin, which has saved countless lives by effectively treating bacterial infections. Penicillin's discovery marked the beginning of the antibiotic era, transforming medical practice and significantly reducing mortality rates from infectious diseases. This life-saving drug has had an immeasurable impact on public health, enabling the treatment of previously deadly infections and paving the way for the development of other antibiotics. These groundbreaking discoveries: electricity, the structure of DNA, Newton's laws of motion, the theory of relativity, the periodic table, the theory of evolution, and penicillin have fundamentally transformed our understanding of the world and our place within it. They have sparked revolutions in technology, medicine, and scientific thought, demonstrating the power of human curiosity and ingenuity. By exploring these stories, we can appreciate the profound impact that scientific discoveries have on our lives, shaping the world in ways that continue to inspire wonder and awe.